Hey guys, welcome to 5.11, solving optimization problems. Literally one of the worst possible things in calculus you can do, which is why I've actually drew flames this time at the bottom of the page. This will hurt your brain, but once you get the hang of it, you get the hang of it. It's similar to related words, we just have to keep practicing it, but I still hate it. And I have this cute little meme. It's like, girls ask, want to see my cute little box? And then send me a 3D box drawing for a calculus optimization problem. And I'm really sorry, guys, but I'm going to have to do that to you guys. Manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with maximum volume? So I'm going to draw a not so great looking box. But, a box I will do. Oh, yeah, I would never want to use this box. I'm covering this, okay. Gonna color most of this black just because, it's an open box and this side is not getting counted in anything we do. Alright, and so they gave us the surface area, which is so sweet of them. They gave us the surface area and they want us to maximize the volume. Volume's what's being maximized. So those are the two equations we're gonna use. Let's set those puppies up. And so let's label our blocks, shall we? We're gonna label this side of our box X, and the height is H. And because it's a cube, or our box is a cube, these are all gonna be, this base is gonna be X. And so the surface area is gonna be equal to X squared plus, because X squared is going to give you that base, and it would usually be 2X squared, but because the box is open on top, it doesn't count, and then X times H, and that X times H is giving you, like, let me get a highlighter, that X times H is giving you one of these sides, and because it's a cube, there's going to be 4 of them, so it actually be 4XH plus 4, I did not want that, plus 4XH. And then your volume is going to be length. Again, volume is length times width times height, which is going to be X squared. X squared H. Volume is X squared H. We're optimizing the volume. We're going to want to use the one with the value we already have because they gave us 108 for SA. So we're going to make that in terms of H. Yeah, I think we're going to make that in terms of H. Sounds good to me. All right, cool. So 108 equals X squared plus 4XH. So 108 minus X squared equals 4XH divided by 4X divided by 4X. So then we get H equals 108 minus X squared over 4X. And then we're going to, of course, take this lovely thing and plug it whoosh, all the way over here into this H. So then you're going to get V is equal to X squared times 108 minus X squared. 108 minus X squared over 4X. And once you go ahead and distribute that, so then volume is going to be 27x. 27x minus 1/4 x to the third. Alright, now we need to find the derivative. Get a new color for this. Find the derivative, which is going to be 27 minus 3 to the 4th x squared. And there's your derivative. And we're going to set this puppy equal to 0. Let's try and solve this out. I'm going to multiply this by 4. Multiply this by 4. It's still going to give you 0. Which is going to give you 108, right? 27 times 108. Yes, 108 minus 3x squared, because these 4's thankfully cancel out. Minus 3x squared equals 0. And then you can just go ahead and divide by 3, which is 36 minus x squared equals 0. And then this turned into 6 minus x, 6 plus x. When you make both of these equal to 0, you're going to end up with x equals 6 and negative 6 for your CPs. You're going to get these for your critical points. But what's important to note is that it can't be negative 6 because x can never be negative. You can never have a length of something being negative. So you're going to use the x equals 6. That's what you're going to want to use. All right, and we're going to use that and plug that back into height to find our height. So then we're going to get h equals 108 minus 6 squared, which is 36 over 4 times 6. So 108 minus 36 over 24. Plug that into a calculator real quick. That gives you 3. So our h equals 3. And now that we have both of these, we're going to go ahead and plug into our volume to find what the maximum volume is going to be. What are our maximum volume? Let's do this in orange. So V equals x was 6, right? 6 squared times 3. And the V is 6 squared is 36. 36 times 3 is 36 times 3 is 108. So the volume is actually 108. Inches cubed. It's crazy. That is actually kind of a coincidence there. That doesn't usually happen where it's the exact same. But yeah, your volume is 108 inches squared, and your dimensions would be x equals 6 and h equals 3. And that would be it. Yeah, that's kind of it for optimization. It's hell, but again, keep practicing.